How many cutting edges did your insert have? Okay, if it's one of the triangular ones, it has 3 on top and 3 on bottom, because you can flip it over and use the other 3, assuming you didn't blow it out so badly on the front side that it's no longer usable, which happens. If you have one of the diamond ones, then you have probably 2. If it's square, then you have 4. If it's square, you have 8. But there aren't very many square ones. How many, what is the included angle on your insert? What did you think? Any idea?
I guess like 80.
I think it's 60.
The included, yeah, so the included angle is like this.
Yeah. Like 70.
75.
Sorry?
Like 70.
70? Okay. All right. It could be, yeah. There are all sorts of different sizes that they can be depending on what they were. We'll look at it in a minute. Yes, 120 was wrong. What does the insert seem sharper or duller than the high-speed steel? I mean, it's significantly duller, isn't it? It's like pretty certain that you could use this without cutting yourself on it until you believe that to be true, and then you'll cut yourself on it. But yeah, interesting how big a difference it is, such that you can completely feel it. Does your insert have a shear angle?
Yes.
It does?
A little bit.
What is it?
Vertical 3K2.
Okay, where does the shear angle happen?
Wait, not the shear angle.
In the cutting process.
Thinking
The shear angle happens in the material, right? The shear angle is from the depth of cut up to the surface. It's in the material. It's a machining process parameter. It's not in here. Does this actually have a shear angle? Well, yes. If I took it and I broke it, it would shear along a certain plane. But the shear angle for doing that would be 45 degrees, almost without question. But anyway, what is the back clearance angle on your insert?
Well, a lot of times they're flat because you tilt them.
That's right. So this one actually doesn't have one because you can flip it over and use the other side. If you did that, then you would reverse that back clearance angle and it would drag. So what normally happens is this will be tilted in such a way in the pocket that it's held in that will give it the back clearance angle. The rake angle of your insert, really hard to tell. There is a little scoop right at the edge, but most often the rake angle of the insert is also set by the holder, and so the holder will make that be whatever they want it to be. And then what features do you have on the top of your insert? And what is their purpose?
A little pattern.
It looks pretty cool.
A little pattern? There's a little, somebody killed a bug on top of it?
The chips.
Yeah, it's to help form the chips and to get them to bend around and to hit the material. It is often got these little fingers to kind of push it back and forth to just to make that process of curling happen better, but without oscillations happening in it. So anyway.
Why does one of the sides have like this little hole on it and the other side doesn't?
Yeah, that is a good question. Why one side has a hole and one side doesn't. When we watch the video about how they're made, let's see if we can figure that out. If that were an injection molded part, why would it have a little hole on one side? It would be a witness mark from the ejector pin. And so that's what it is here too. There's a little ejector pin that pushes it out of the press where they squash it. And so, yeah. All right, I'll take those back. Actually, maybe I ought to put that in the other one. I don't know. Which was that? Yep, I know, you did. So, an interesting thing about carbide can cut metal all day long. But if you take the carbide, if I took it and dropped it from here onto the steel, I could easily damage this carbide enough that it would not be usable. So when you're dealing with carbide, you have to be pretty careful with it. So there is an admonishment on here to hold it over a table or a student. We don't have to do that in this room because we have plastic top tables and we have a carpeted floor. But the last time I taught this, we were in Fraser 1.0 something. And in there, dropping it on the floor, the concrete floor, would have broken them forever. So anyway, and they're really expensive. They're crazy expensive for what you get with them. Depending on the insert, they can be between $20 and $150 a piece, depending on how complex they are.
Does the tungsten, like if you were to take that box and shake it around, would it scratch itself?
It will shatter. It's just brittle. So yeah, you can't. So I carried all of these end mills in this happy little box. That's because they're high-speed steel. If they were carbide end mills, I would not have put them in a box together to carry them around. You'll notice next year when you take 332 that we store our carbide end mills in their little cases to keep them from banging into other stuff. Yeah. Okay, we should take a break because forever. So like 18 or 19 after.